A couple things. What do you notice about the four formulas that you have to use for secant and cosecant? What do you notice about these four formulas on here? Yeah, they're exactly the same as sine and cosine, okay? One note here on the yellow sticky that's really important that I want to just go ahead and say it again is that when it comes to sine, cosine, secant, cosecant, any question that I write, now I'm not saying any question that my lab writes, okay? Any question that I write, so like on the upcoming test, you know how I told you there's going to be a paper portion? Any question that I write, I will only ever ask you for one period, okay? I will only, that's a promise. Now, my lab might write a question that asks you for 2 periods, or it might ask you for draw everything between 0 and 2 pi, and maybe that's 1 period, maybe that's 1.5 periods, you don't really know. Just depends on the problem. But if I write you a question, I promise that it will only be 1 period for sine, cosine, secant, cosecant. If you see anything different on a question I've written, you have my complete permission to question me. Same as Robert, I thought you said that there was only going to be 1 period asked for here. Is this a typo? Because it might be. Okay. So if you see a question that I've written that's not that way, ask me about it. Again, that's for sine, cosine, secant, cosecant, only those 4. So the big deal here is just make sure when we're graphing secant and cosecant that you already are well familiar with 9-6, the sine and the cosine graphs. If you're not familiar with what we did last week on Monday, the sine and the cosine graphs, you're already kind of starting on shaky ground today. Okay, because you gotta know sine and cosine graphing to be able to do secant and cosecant graphing. Okay, so just make sure that your familiarity level is really good. Okay, so let's just go right ahead, and you'll need the little notes that I gave you in the video. Let's go ahead and just jump right on in. So let's find everything in graph. Now, as you see example 1, is there a way that you would rethink example 1 or maybe rewrite example 1? Thoughts? Yeah, put the 1 in the back, either on paper or in your mind, it doesn't matter, but you need to think about the fact that 1 is not your A value. 1 is not your A value, okay? So you can rewrite it if you want. If you were to rewrite it, you would have, let's see, that's a little bit too skinny. You would have -2 cosecant x plus pi over 2, and then +1 out back, okay? And again, you don't have to write that, but you should at least think that. Okay, so let's talk through. What kinds of things do we know according to section 9.6? If this were a sine or cosine, and it said find everything in graph, what would you do? What do we know? Let's start with amplitude. 2. Okay, what else do I know? There's a reflection. What makes it reflect? Okay, so reflect over the x-axis. What else? Okay, period. And what's my period? Yeah, how do we know it's 2 pi? What's the formula? 2 pi over b, and in this case, my b is 1, okay? Because that's what's out in front of the x, all right? So 2 pi over 1, which is 2 pi. What else do I know? Phase shift. And what's my phase shift here? Okay, so to the left, I think I heard pi over 2. Why is it to the left? Opposite from what we expect. Okay. And is there anything else? Yeah, my vertical shift or the vertical translation. And what is that? Up 1. One more time, I mentioned this last week, but just to remind you, as you're working through my lab, remember my lab will accept things like instead of saying to the left pi over 2, they'll accept negative pi over 2. I don't even know what it does. I don't know if it does negative pi over 2 or positive pi over 2 because I'm like, I don't. Yeah. So just remember, whatever it does, I won't allow that on the paper portion of the test. I actually want you to write left pi over 2. Don't just give me a plus or a minus, because a plus can mean two different things. It can mean I'm going right. It could also mean I'm going up. So I need to know that you know which direction you're going. All right, so that's my find everything. Now let's go graph. As you look at this, plan out in your mind, first of all, which direction you're gonna go, and ask yourself, is there enough room on the paper to graph it by keeping it normal, or do I need to squeeze things in at all? Yeah, I can keep it normal because I'm going which direction? To the left. So I've got room to go to the left. I'm probably gonna have to extend my x-axis, but that's it. Oh, straighten up. Let's try that again. Okay, so my iPad thinks it's Monday morning. There we go. Thank you. Okay, so let's see here. What should we start with? Or maybe the easier question, what can we ignore at the beginning? Do you remember? This is a sine and cosine question. So this is something that we did in 9-6. What can we ignore initially? The shifts. Yep. Remember, we want to get our 5 magic values pre-shift. Okay. So I can ignore the vertical shift and I can ignore the phase shift for now. Let's just get the 5 magic values. And honestly, guys, we can be thinking sines and cosines. I don't even have to be thinking secants and cosecants yet. Okay. So, so if we're going to ignore our shifts, let's only pay attention to the amplitude, the reflection, and the period. So since the period's 2 pi, let's take that all the way out to the end, just like we did with sines and cosines. Okay. And what was that 3-step phrase that I kept saying last Monday? Once you have the ending, take half, and count. Okay, so when you take half first, we get, this is one of the boring ones, right? Take half again, pi over 2, and then we can count 1 half, 2 halves, 3 halves, 4 halves. Okay, let's go ahead and put our amplitude on here. I will say this is just a hint. I probably didn't mention this on the video, but this is just a little tip. When it comes to secants and cosecants, instead of really stretching them out, you know how like a lot of times if it were like my amplitude was 1, I'd give it like 3 or 4 blocks and I'd really stretch it out. When it comes to secants and cosecants, I don't do that. I keep everything close to the x-axis. Because think about what's happening. My activity isn't close to the axis. My activity is way out on the outer edges of that. Okay, so I kind of keep my numbers close to the x-axis on secants and cosecants. Okay, now, at this point, I do have to pay attention to whether it's a secant or a cosecant, but I'm still thinking in terms of sines and cosines. So this is a cosecant graph. Whose partner in crime is cosecant? Sine. So what we're going to do is we're going to get the 5 magic values for our sine graph. Okay, not for our cosecant graph, but for our sine graph. Okay, so where would my 5 magic values for my sine graph be? Yeah? Maximum? Thanks, Aaliyah. Good job. All right, so so this is my sine magic values. All right, now let's see how much you actually learned from the video. Okay, there are 3 spots: the beginning, the middle, and the ending, where my sine graph is on the x-axis. Okay, so if my sine graph lands on the x-axis, what's happening with my cosecant graph? It's an asymptote, okay? So when I shift in a few minutes, I'm gonna be thinking about the fact that when I shift the beginning, middle, and end, I'm not gonna draw a point, I'm gonna draw an asymptote, okay? So my beginning, middle, and end is going to be my asymptote once I shift them, okay? What about the maximum? A maximum sine becomes what? A minimum cosecant. So when I shift that guy, it's no longer going to be a maximum. I'm going to turn it into a cosecant minimum. And then the same thing here, it's a sine minimum. It's going to become a cosecant maximum. Okay, so think about that as we shift our 5 magic values. Okay, so the magic occurs when we shift. Okay, so it says that we're supposed to shift left pi over 2. How many blocks is that going to end up being for me? Yeah, 4 blocks. So I'm going to shift all 5 of my magics left 4 blocks. Okay, but then there's also a vertical shift. So what's my vertical shift? Yeah, I'm going to shift up 1. And in this case, up 1 is going to be up 1 block, okay, because I said 2 blocks is equal to 2. Did you have a question, Michelle? Good catch. Good catch. Now, sometimes I let y'all make a mistake and I don't stop you to see if somebody will stop you. This isn't the case. I actually forgot about it too. So I'm not the only one that forgot. But thank you for catching that. Yeah, we forgot our reflection, didn't we? We forgot our reflection. So let's change. The only thing that's going to change is our max and our mins, right? That first maximum, let's change that to a minimum. And then that minimum, let's change it to a maximum. Thanks for stopping us before we got too far, because that's a pain when you go too far and then you have to redo a whole lot. Easy fix so far. Okay. Now we're ready for our shifts. Let's take our 5 magics to the left 4 blocks and up 1 block. Is there a yardstick back there somewhere? I was hoping there would be a yardstick in here. I didn't want to carry one with me to class. No yardsticks? Okay. Well, then you're just going to have to deal with my arm as a yardstick. Okay. This is my asymptote. All right. So remember that this first guy here, when we shift it, it is going to be an asymptote when I draw it. Okay. So I'm shifting my asymptote to the left 4 blocks. Does it really matter if you shift your asymptote up 1 block? Does it look any different? No, it doesn't. So go ahead then and shift that asymptote to the left 4 blocks. When you draw it, don't draw a point, draw an asymptote. All right, next, let's go shift our minimum. Okay, so again, don't forget, you've got 2 different types of shift. You got to go left 4 blocks. You also have to go up 1 block. Okay, now this is going to be a point. Okay, it started out as a point, it ends up as a point. So left 4 blocks, up 1 block. I'm going to draw just a dot. Left 4, up 1. And let's remember, it used to be a sine min or max. It was a sine min or max. This one right here. It was a sine min. So what's it gonna become? Max. So what I'm gonna do, just so that I'll remember that it's a maximum, I'm gonna put 2 tiny little legs on it just to remind myself it's at the top of this curve. It's not at the bottom of this curve anymore. It's at the top. Okay, and those 2 are just, you don't have to do that. It's just a reminder because I'm forgetful. Okay. All right, so that was my sine minimum. Now let's go back to the x-axis. When I shift this guy, what am I going to draw? An asymptote. Okay, so shift this guy to the left 4 blocks. And up 1 if you want to. It's just going to be an asymptote. Then we have our sine max. So let's take that guy left 4, up 1. I'm gonna put a dot there. Now it was a sine max. What does it become? It becomes a min. So again, I'm gonna just give it 2 little legs to remind myself that it's at the bottom of the curve. It's the minimum of that curve. Okay, and then the last thing that we have to shift is that last x-intercept. And when I shift that guy, what will it become? It's an asymptote, so let's shift it to the left 4. Okay, and now the only other thing I have to do is just to draw my curvy pieces. Remember that asymptotes are fences, okay? You get closer and closer and closer and closer and closer to an asymptote, but you never actually touch it. Just for a little bit of a practice for a moment, if this question asked you for the range, what would the range be? Negative infinity to -1, and what kind of a symbol would be on the -1? A square bracket, yep. And then you would have the or symbol, union. What's the next piece? Square bracket 3 all the way to positive infinity. So you've got that space in between -1 and 3, which is where we would have drawn sine if we were drawing a sine graph, but we're not drawing a sine graph. Okay. All right. Now let's go do the same thing for secant. This follows along very, very, very closely. All right. So then let's just look at the equation first. What are some things that we need to do? Yeah, so that 2 out front, let's shove it to the back. Is there anything else?
Would you undistribute the 1/2 from the x?
Absolutely, Marina. Yes, very good. So you're going to undistribute. That's called factor. Okay, so we're undistributing or factoring the 1/2 out of those 2 terms. So we've got 2 times the secant of 1/2 x minus. So I did the easy one, okay? But remember, factoring is just division, all right? So in my mind, now some of you already know this in your head, and so you don't even need my help with this. But think about it. You had a 1/2 x. We divided out a 1/2. That's why we got x. You want to do the exact same thing with the second term. The second term is a negative pi. So you want to take your negative pi. You want to divide out a 1/2. And what will you get when you divide a 1/2? Negative. No. How do you divide fractions? Yeah, you have to multiply by the reciprocal. Okay, so make sure you flip it over on bottom and then multiply. And so I think I heard of it. Can you guys just say it again? Yeah, -2 pi. Question, what would be a good way to check your work just to make sure you did that correctly? Good, redistribute the 1/2. If you redistribute the 1/2, you should get what you started with. Okay, for the record, guys, I've been factoring, well, for sure longer than you've been alive. It's possible, maybe even longer than your parents have been alive. I just got really depressed, okay? So I'm still, when I factor, my mind, mentally, I still redistribute just to make sure I did it right. Okay, so if I'm still doing that, even though I've had tons more practice than you have for factoring, it's just a good habit to get into. All right, so now that we have a good standard equation, what's my amplitude? 2, okay, how about my period? Tell me how to find my period. 2 pi over 1/2, and what's that gonna equal? 4 pi. Okay, so don't forget you're multiplying by the reciprocal. All right, how about the phase shift? To the right, 2 pi, and then the vertical shift. A lot of 2's in there. What graph are we actually thinking about from the beginning? The cosine graph. Yeah, the cosine graph. Okay, so for now, let's just pretend it's cosine. We'll get our 5 magics, pre-shift, and then we'll deal with what to do next. Do I have space? Do I need to worry about compressing anything? Or do I have space? Are we good? Anybody? Yeah, I think there's enough space because I'm moving to the right. And I'm gonna extend my x-axis. So what's my ending here? Four pi? Take half. 2 pi. Take half again. Pi. Count. 1, 2, 3, 4. Amplitude is 2. Okay, so where are my magics? Again, you're thinking cosine. Where do I begin? Maximum, and then? Oh, and then? Back to the x-axis, ending where? Maximum. Okay, so talk to me then. This is cosine. So far, I've only paid attention to cosine. Now we're ready to make the switch over to secant. Okay, so talk to me about these 2 maximum values. What are those 2 maximum values going to become when I shift them? They're going to become secant minimums. What's this guy going to become? A secant maximum. And then what are these 2 guys going to become? They're going to become asymptotes. Okay, now let's talk about shifting. How many blocks to the right will I need to shift? 8 blocks. Yeah, because it says that we're shifting to the right 2 pi. And notice that right now, my 2 pi is taking up 8 blocks. So every single coordinate is going to shift to the right 8 blocks. And what else? Up 2 blocks. Up 2 blocks. Okay. This one, tell you what, when I do my shifts, I will change colors because I told you guys that you can use multiple colors if you want to. The last one I did all in the same color. This one I'll do in a different color, just so that you can see what it looks like. All right, so let's take our very first maximum. Let's shift it to the right 8 blocks and up 2 blocks. And we said that because it was a maximum, it's now going to become a minimum. So it's going to be at the bottom. We're going to just, you don't have to put those there, okay? But I'm forgetful, so I put those there just so I remember it's a minimum now. It's going to be at the bottom of my curve. All right, this guy, let's shift it to the right 8 blocks. And you said it was going to become an asymptote. And I'm just now thinking of something that I forgot on the last question. You guys know what I forgot on the last question? It's pretty simple. What did I forget? What is it? I don't actually know if what you're saying is correct because I can't understand it. Yeah, my missing values. Remember, all 5 magics has to have a value. So I missed the very first one at negative pi over 2. Like I said, it's pretty minor. But we do need to do that correctly. So, okay. So let's get back to this one then. I shifted my asymptote to the right 8 blocks. Sure, you can say you shifted it up 2 blocks, but it doesn't look any different. Now let's go to that minimum value. We'll shift it to the right 8, up 2. And since it was a minimum, now it's going to be a maximum. It's going to be at the top of that curve. That point that was on 3 pi, let's shift it to the right 8 blocks. It's going to be an asymptote. And then last but not least, what used to be a maximum will go to the right 8 blocks and up 2 blocks. It was a maximum, now it's going to be a minimum. All right, now let's draw the curve, okay? The middle piece, that's the easy piece because that's a whole entire curve. But for the outer 2 pieces, by the way, the little sticky note that I started off the class period with, what was that little sticky note? You always draw 1 period for sine, cosine, secant, cosecant. So let me draw something. Don't copy me because I'm going to have to erase some of it. If I were to draw this, did I only draw 1 period? No, I drew more than 1 period. So you would just simply for, not because it's wrong, but because it wasn't following the directions, there would be some points taken off. Okay, so now I'm beginning and I'm ending at the exact same place, at the exact same Y value. Now I have only drawn 1 full period. So I would be able to get full credit for that. Does that make sense? So it's like you're drawing 1 full curve and then 2 half curves. Any questions for secant, cosecant? Okay. All right, so take a look at the standard equation for tangents. Does the standard equation differ at all? Does the standard equation, is that different? It isn't. I mean, unless you want to say it's got a tangent instead of a sine, cosine, secant, or cosecant. But as far as all the other letters, they're all the same. Okay, the standard equation hasn't changed. What has changed? The period. Okay, the formula for period is now pi over b instead of 2 pi over b. And the reason for that is because it starts repeating itself every pi, not every 2 pi like the other 4. Okay, look at the sticky note. What's different about the bottom of that sticky note? You have to graph 2 full periods. On any question that I ask you, when it comes to tangent and cotangent, I promise you, I will only ever ask you for 2 full periods. My lab might ask you something different, okay? But me personally, any question I write, I will only ask you for 2 full periods. That's a promise. The reason for that, like, because I know students are like, Ms. Hortz, can't you just keep it consistent? So I had a choice of what to keep consistent. If you draw 2 full periods, you still get 5 magic values. Okay, so either I was gonna keep the 5 magic values piece consistent, or I had the choice to keep the periods consistent. And so I just said, okay, we'll draw 2 full periods. That's how you get your 5 magic values. Okay, so just keep that in mind. I'm gonna change things just a little bit as we draw it, but I think you'll catch on pretty quickly. I will say this, I don't know if I can show these 2 at the same time. Let me see if I can. So what do you notice about the tangent graph that's different from the cotangent graph? How are they different? Because the curves look a lot alike, but how are they different? Yeah, so the tangent is always increasing. It's always going uphill, whereas the cotangent graph is always going downhill, the parent anyway. So let me just say this to help you remember this. This is not mine. A student told me this years ago. He says, Ms. Roberts, you know, if all you do is drink Coca-Cola, then probably your body is going to go downhill. And I said, oh, okay, thanks for that information. I agree with you. Ms. Hartzell, did you get it? Coca-Cola, cotangent, downhill. Right. So if you come up with something better, let me know and I can share it with future classes. But for now, that's what we got. Okay, so the cotangent graph always goes downhill. You can think of that as Coca-Cola. If that's all you drink, your body's going to go downhill. All right, so let's go ahead. The other thing to memorize, what's happening on a tangent graph at the beginning, middle, and ends? Tangent graph, beginning, middle, and end, what's happening? Yeah, it's on the x-axis. Cotangent, beginning, middle, and end, what's happening? Asymptotes. I would just say that's just a little bit of something to memorize, okay? I mean, you can redraw and rethink about the parent every single time, or you can just memorize that little bit. Okay, so let's go ahead then for example 3. We'll find everything, and we will graph 2 full periods. Okay, what's the amplitude here? Now, let me say something about the amplitude. When it comes to tangent and cotangent, it's harder to see the amplitude on the graph. I still want you to give it to me, but I'm not really going to ask you to graph it. Okay, so you still need to put it in your list so that I know you didn't forget about it, but don't worry about graphing it. Okay, how about the period? Okay, Aaliyah, why would you say it's 2 pi? Ah, where do you get 1/2 from? Yeah, this is the same thing as 1/2 times x. Okay, so our b value is 1/2. And remember, this is the formula that's changed. Okay, so it's pi over b, not 2 pi over b. Pi over b. So it's going to be pi over 1/2. Invert and multiply, so that's going to be 2 pi. What's your phase shift? Now, what have we not done that's going to mess us up on this step right here? Yeah, we haven't factored yet. Okay, and everything's okay up until this time. So you've got to make sure that you factor, put it into standard form before you get that phase shift. Everything else will work out for you, but the phase shift won't. So let's go ahead. We've got tangent. What are we factoring out? A 1/2. So what's that going to be? I feel like that's the exact same numbers that we just used in the last question. I could be wrong. Remember, you're dividing, right? That's 2 pi. Pi divided by 1/2. Okay, so now tell me what the phase shift is. Left 2 pi. So I gotta admit, as a teacher, I cringe when I see that the period and the phase shift are the same, because this just turned into a boring question. Personally. Okay, I hate boring. All right, no vertical shifts, so we're good on that. No reflections, we're good on that. So let's go ahead and just jump right on into our graph. Just like with before though, I want to do everything that I can pre-shift. Get your 5 magics pre-shift, okay? So where is the ending of this guy? 2 pi, but how many periods are we supposed to be drawing? I'm supposed to be drawing 2 periods. So here's one of the things that's different. Yeah, my ending is 2 pi, but that's the ending of the first period. Okay, not the ending of the second period. So what I'm going to do then, the ending of my first period is going to be in the middle, because remember I have to draw 2 full periods. So then where will the ending of my second period be? 4 pi. So now I only need to take half one time to get that first quarter point there. So it'll be pi, and then you can count 1, 2, 3, 4. You can put your amplitude on the graph, but again, it's really not going to have any effect on the shape of the graph. Okay, so here's where you have to be thinking. This is part of what you've memorized, okay, or what you're gonna memorize, so you might have to look back this first time. What happens on a tangent beginning, middle, end? X-intercepts, or are they asymptotes? They're x-intercepts. Okay, so this is pre-shift. So let's get ourselves 3 x-intercepts beginning, middle, and end. Okay, what happens at quarters of the tangent parent? Asymptotes. Now, because this is pre-shift, what I'm going to do is I'm going to put asymptotes in, but super, super, super lightly, like just a couple of little dots so that I can know it's there, but this is so not my final answer, Miss Roberts. Okay, it's just, it's there. So there's my 5 magics. I've got 3 x-intercepts, 2 asymptotes, total of 5. So now let's take care of the shift. We want to shift everything to the left 2 pi. How many blocks is that? 8 blocks. Okay. No vertical shift. So then let's take our first x-intercept backwards 8 blocks. Did I forget to count again on the last question? Yes, my goodness. Well, I guess you guys can see the chink in my armor. I'll go back and do that. Just don't let me forget. I might as well do this right this minute. What is this point? Where is it? Negative 2 pi. Okay, so that's my first x-intercept. Now take your asymptote, left 8 blocks, and I'm going to draw it for real this time. And where does that land? Negative pi. And then my middle value is another x-intercept. Let's move it to the left 8 blocks. It's going to land on the origin. And then my asymptote that's at 3 pi, left 8 blocks. Here's why I think it's boring, because it lands on top of another asymptote. And then lastly, that ending value at 4 pi, shift it to the left. All right, now, tangent graph. I got to draw my curves. Uphill or downhill? It's going uphill, okay? So remember, how many periods am I drawing? 2. That means I've got duplicates of everything I draw, okay? So when I start out at the first x-intercept and use my asymptote as a fence, I've got another one of those. Since I'm drawing 2 periods, I have to draw that same curve 2 times. I should have 2 identical pieces because it's 2 periods, okay? And then I also have, because I've left some out, right after the first asymptote, I need to go up to meet that x-intercept. But I should have 2 of those as well. So then I've got duplicates of everything. We good? Okay, so then cotangent example. Yes. Thank you. Man, why do I keep forgetting that? Okay, so this is back on example 2. What were the 2 magic values that I forgot? 5 pi and 6 pi. Okay. All right, so in just a minute, you guys are going to be in charge of doing example number 5. Okay, so be prepared. You're going to be working example 5 on your own or with a partner. I'm fine with that. But let's go ahead for example 4. Okay, we'll work this one together because this is the first cotangent graph we've done. What are my thoughts first for cotangent? Did you say we can go ahead and get our asymptotes? I gotcha. Yep. Parents say that it's going to be beginning, middle, and end asymptotes. Very good. What's your amplitude? Somebody else. What's the period? Savannah, what's the period? Good. Yes, absolutely. So what are we factoring out? A 2. Oh man, this is gonna start. Sorry guys. This is what happens when you have a large family and somebody, my mother, starts a group text. So when I factor out that 2, what am I left with? Did you guys figure it out? 3 pi? Okay, so if I write down 3 pi, and if you redistribute, is that right? No. Okay, so that's okay. Hey, you've already seen me make a couple of mistakes today, so I'm totally fine with mistakes. Try it again. Say it again, Yami. 3 pi over 4, good. 3 pi over 4. Okay, so now, Savannah, can you tell me what the period is? What's the formula? You can look it up, I don't mind. Because we just learned it today. Okay, so it's pi over b. Yep. All right, and let's see here. Myona, what is the phase shift? You guys agree with her? What do you disagree with? The direction? Why is it right, Myona? Yeah. Yep. And then there's no vertical shift, so we're good. Okay. And it looks like we have space. Since we're shifting everything to the right, let's go ahead and extend our x-axis. Okay, so where's our ending? That's kind of a loaded question. Where? So I'm going to say, I'm going to agree with the pi over 2, but then that's the end. When I say where's the ending, that's the ending of what? The first period. Yeah, so pi over 2 is the ending of the first period. And then what's the ending of the second period? Yeah, pi. So then let's go back to that middle point and take half of the middle guy, and what do you get? Pi over 4. I don't know what's going on with my iPad here. And then go ahead and count. So 1/4, 2/4, 3/4. Okay, so Juan, let me come back to you. What did you say about the beginning, middle, and ending? They're going to be asymptotes. So once again, I'm just going to kind of throw in a few dots. You can't even see them on my beginning because they're so tiny. And what happens at the quarters of the cotangent graph? Yeah, x-intercepts. So I'll put x's there. All right, now we want to take our 5 magics and we want to shift them. How many blocks do we need to shift? 12 blocks. 12 blocks to the right. Okay. All right, so our first guy is an asymptote. Let's shift our asymptote to the right 12 blocks, and I'll draw a real asymptote. The next guy is an x-intercept, so 12 blocks down the line lands me here on pi. Then my middle asymptote, 12 blocks down the line. I need a value for that, don't let me forget. And then an x-intercept, 12 blocks down the line. And then last but not least, my last asymptote. These are spaced out really nicely so that I can just keep on counting. So you had 1/4, 2/4, 3/4, 4/4. So what's that next asymptote? 5/4. And then the x-intercept? 6/4, but what will I write? 3 pi over 2, 6/4, and then the last asymptote? 7/4, right? 5/4, 6/4, 7/4. And then which direction does cotangent go? Downhill, right? So you're starting at your fence and you come down to meet the x-intercept. But remember, you got to have 2 of those guys because there's double periods. So the next asymptote, you want to do the exact same thing. And then pick up with the x-intercept again, keep on going downhill to approach the fence. And you want 2 of those as well. Okay. Now, for example 5, I don't want you doing this alone. I do want you doing this together. All right. Natalie and Marina, I don't know how easy it would be to work together on Zoom. You're welcome to do that. If that's too difficult, Marina, do your best, and Natalie, just join maybe Juan and Dylan. Okay, but whatever you guys can work out is fine. But it shouldn't be quiet, okay? You guys should be working together on this next one. And I couldn't do it. I just saw a fraction.
Oh, my picture of that. Yeah. I'm not requiring that you I just go ahead and look at the graphic. It's
If you feel like you finished this example, number 5, you can go ahead and start on number 6.
What are your limits? Sounds good to me. Sine. So sine would start out with
I don't even know. So then what do you need to
all our sets Are you still running? I'm trying to help out these two people. Free shift and is 3 power. Okay, check. Bro, you see how you have a 2 right there, right? So you take it back out 2.
No, I mean like
grab. So that's just gonna be you're gonna have to shift 4 as well. You gotta shift the whole thing. Well, it's 3 5 2. That's already 1 5. You gotta help my group. I'm so sorry.
and you have to use how many blocks on
That's where you have.
Oh wait, no,
3 power 2 is there.
Hold on. Let me think about that. How much is the wire? Let's go.
Yeah.
3 power 2. 2 power 2 3 times. 3 power 2 is 1 basically.
more blocks. I'm not sure. Get the shit all over magic.
Now multiply over to the 6 pi over 4. 6 pi over 4. You now just realize that now.
That's why we were talking. So let's do, this is pi over 2.
You guys don't remember. No one mentioned it.
Alright, we both did.
So then we do.
Now we have
Okay, so.
So. We put 2 pipes in here. Because we had to ship everything to the height and we did this is 2 pipes. So we squeezed everything into 2 marks and made our own older marks. And then a whole entire It'll be fine. It'll be fine. How many points are you having? How many boxes? From what I counted.
I don't think there's. I gotta read.
So this is why it's good to think ahead to see, am I gonna have enough space in Marina, how are you doing?
Now we ship 16 blocks. And then go down.
How many boxes? It's right there.
Oh, that's where you want to be.
Yeah. So then, what should you probably do?
I went as far as 11 high before. I can always do that.
What was the major issue on number 5 when you guys started this, or when you were getting ready to graph? What did you find? Yeah, that phase shift was so stinking long that you probably had to do some compressing, didn't you? Okay, so all right, so far, let's go ahead, let's see what we've got. And if you aren't quite finished, then watch what we do here, and then you can finish up as I finish it up. So I've got my list, my amplitude, period, phase shift, and vertical shift. So just make sure that your 4 things in the list match up with that. And then normally, if we're graphing our 5 magics pre-shift, And probably what you did was you said that the ending was at pi, and that's okay, except for the fact that you end up running out of room, okay? So it was better, instead of saying that that is pi, let's call this guy my ending value of pi. Take half, that's pi over 2, and then you have to draw in your own quarter point, so that's going to be a 1/4, 2/4, 3/4, and 4/4. So this is all pre-shift, okay? Now this is cosecant, so really what is it that I have in my mind for the moment, just to get my 5 magics? Yeah, I need to have the sine graph in my mind. So we've got then, it starts at the origin, goes to the maximum, back to the x-axis, minimum, sorry that's in the way, and then the x-intercept. So those are our sine 5 magics, okay? Now we're ready for the shifts, and this is where we run into some difficulty. So first of all, I got to shift to the right 3 pi over 2, but 3 pi over 2 is not even on my graph yet. So I have to go a little further to find 3 pi over 2. So if I were to keep on counting, we have 1/4, 2/4, 3/4, 4/4. After that is 5/4. After that is 6/4, but 6/4 reduces to 3 pi over 2. So I'm looking at this now and I'm saying, that means I need to shift everything to the right 2, 4, 6, 8, 10, 12 blocks. Everything's going to go to the right 12 blocks. Okay. Oh, but wait, there's more. Because not only did I have a phase shift, I also had a vertical shift, and my vertical shift had to go down 1 unit. Now, look at my blocks. I don't know if you did this the same way that I did, but if I have to go down 1 unit, how many blocks is that? That's 2 blocks down if you do it the way that I did, okay? Because I put a half as 1 block, so to go a whole unit, I have to go 2 blocks. All right, one more comment then while I'm sitting right here. Beginning, middle, and ending are on the x-axis. When I draw those, what are they going to become? Asymptotes, okay? So let's shift the 3 asymptotes first. That might be easiest. So let's take our first guy. Let's shift it to the right 12 blocks. So that's going to land here on 3 pi over 2. Now, there's a different way that I can look at this. Yes, I could take my next asymptote, which is right here, and I could count 12 blocks over, or I could just tell myself, hey, that's only 4 blocks away from the first asymptote, okay? So either way, it doesn't matter. 4 blocks later, I'm gonna have an asymptote. And 4 blocks after that, I'm gonna have an asymptote. Yes, I am gonna need values for those. Okay. Let's do that because I know me, I'll forget. So let's go back counting at 5, or counting by fourths. So there's 5 pi over 4, 6 pi over 4, 7 pi over 4. What's the next one? Yeah, 2 pi, because that's 8 pi over 4. What's the next one after that? 9 pi over 4, and then the last one? Yeah, it's 10 pi over 4, which is going to reduce to 5 pi over 2. Okay, now let's go and shift our maxes and mins. So this is a sine max. It needs to go 12 blocks to the right, and it needs to go 2 blocks down. So 12 blocks to the right is going to land me right here. But then I need to go 2 blocks down from that. So I'm going to have this right here. Now that sine max is going to become a what? Yeah, it's going to become a cosecant minimum. So this is going to be at the bottom. It's at the bottom. And now let's take our sine minimum, this guy. Let's go 12 blocks to the right and 2 blocks down. It's going to land here. It was a sine minimum. Now it's going to be a cosecant maximum. So it's going to be at the top of my graph, top of my curve. And that's all I need then to graph my curves. So that one, to me, what's challenging about that one is just simply thinking ahead and making sure that you've got the space necessary to draw what you need to draw. Okay. By the way, I'm trying to remember on the test, the graphs that I've provided, I don't even think there's tick marks. I think it's just an x-axis and a y-axis. And if I remember correctly, I even kind of center the y-axis so you can go either direction. Okay, but you're the one who decides where the tick marks go. All right, how am I doing on time? Is this the last one I have? I have 13 minutes. You guys want to get a start on this one? Okay, go ahead, get it. Again, work in your groups. See what you can do with this one.
Yeah. I mean, period. Yeah, period thinking.
Marina, you good? Okay.
So we're gonna go to the middle. Well, the power four is how many blocks? 8 blocks.
All right, so let's go ahead and do this one to make sure that we have enough time. So even if you're not finished, go ahead and just pick up wherever we meet each other. So check your 4 there. Check your standard equation. I'm pretty sure I got around to everybody to check, most of all, the period. Okay, so what was different about this period? What was it you had to remember? The tangent and cotangent formula is different than the other 4. So that's probably the most common mistake made on the test. So just watch out for that. How many periods will I be drawing for this, even though there's not a specific set of instructions? Yeah, it's a cotangent, so we're going to be drawing 2 full periods. Okay, so let's get our 5 magic first. Since we're drawing 2 full periods, the ending of my first period is going to be at pi over 4. So where will the ending of my second period be? Pi over 2. Yeah. And then if you take pi over 4 and you take half of that, what's half of pi over 4? Pi over 8. So here's a number that we're not really familiar with. We don't usually work with pi over 8s, but that's fine. So 1/8, 2/8, 3/8, 4/8, and that checks our work along the way, so we're good. Okay. To get our 5 magics, for cotangent, what happens at beginning, middle, and ends? It's an asymptote, so I'm going to just go lightly with my asymptotes here. And then at the quarters, x-intercepts. And so my 5 magics are drawn. So now let's take our 5 magics and let's shift them all to the left pi over 4. How many blocks is that? So everything's going to go 8 blocks left and down 2 blocks. Well, right now, I don't know what down 2 blocks means until I assign what 1 unit is. So I'm just going to go ahead and make 1 block 1 unit so that I'll know what down 2 means. Okay, so then the first guy, let's shift it backwards 8 blocks and draw our actual asymptote. X-intercept, backwards 8 blocks, but don't forget to go down 2 blocks. The next asymptote, backwards 8 blocks, that's going to land right on top of my y-axis. X-intercept, backwards 8, down 2. And then the last asymptote, backwards 8. Cotangent graph, uphill or downhill? Yeah, it's downhill. So there's the first piece of the first period curve. I need a duplicate of that for the second period. And then the rest of the curve, also duplicated. And I need 2 more magic values down to the left. So what's that first one that I run into? Yeah, this one's negative pi over 8, and this one's negative pi over 4. Any questions on that? If this one were to ask, what's the range? What is the range of this graph? Yeah, all real numbers, negative infinity to positive infinity. Okay. Please, as you're working your homework, please make sure that you are accessing the paper version of your homework, and that you, again, I'm not grading that, but it's there for you. Have you guys found what I'm talking about there on my lab, the paper version of the homework? Okay, so make sure you're looking at which problems to do. You can also check your work because I've provided all of the solutions to that. Dylan?
So maybe
Nope, nope. I still want you to list it. And like in this case, we still use it, sort of, because we're assigning it one block. The amplitude is 1, we're assigning 1 block so that we can shift up or down. But it doesn't really make the graph look much different. If you were to graph it on a calculator, what would happen is it makes the curve either shallower or deeper. But I'm not gonna make you guys graph that much. Okay? All right, guys. See you Wednesday. Marina, thanks for coming. Hope you feel better.
Thank you. Bye.